Welcome back, children. The next topic, geometric mean. So if A and B are two positive numbers, then their geometric mean, the notation is GM. If A and B are two positive numbers, then their geometric mean is defined as root of AB. That is why A and B must be positive numbers. If it is negative, inside the root negative imaginary numbers will come. So A and B, if A and B are two positive numbers, then their geometric mean is defined as root of AB. For example, if 2 and 8 are two numbers, then what is the geometric mean? Geometric mean of 2 and 8, root of 2 into 8. That is root 16, that's equal to 4. Root indicates only positive value, so it is 4. Now, what is the resultant sequence? So, 2 and 8, two numbers, we can insert this number, that is their geometric mean in between. Now, what about the sequence? Is it a GP ratio? Take the ratio 2 into 2, 4, 4 into 2, 8. Then again, find the geometric mean of 2 and 4. 2 and 4, the geometric mean is 2 into 4, that's equal to root 8, that is 2 root 2. So, in between I can insert 2 root 2. Then 4 and 8, what about their geometric mean? 4 into 8, that is root 32, so that is 16 into 2, that is 4 root 2. So, after 4 I can write 4 root 2, then 8. Now again check the sequence. Is it a GP? 2 into root 2 is 2 root 2. 2 root 2 into root 2 is 4. 4 into root 2 is 4 root 2. 4 root 2 into root 2 is 8. So root 2 is the common ratio. So like that we can insert as many numbers in between two positive numbers so that the resulting sequence is a GP. So suppose we insert n numbers in between two positive numbers A and B. Let G1, G2, G3, etc. Gn be n numbers inserting between two positive numbers A and B. So now there are how many terms? There are here n, then plus 1, plus 1. So there are n plus 2 terms, and the resulting sequence will also an AP. So B is the n plus 2th term, isn't it? N plus 2th term is B. Now write the expression for n plus 2th term. It is GP. So n plus 2th term is first term into r raised to n plus 2 minus 1. That is A r raised to n plus 1 is B. So r raised to n plus 1 is B by A. Or what is r? B by A whole raised to 1 by n plus 1. So in this way we can find the common ratio if we insert n numbers in between two positive numbers A and B. Now G1. It is the second term. So G1 is obtained by multiplying common ratio to R. So G1 is first term into common ratio. Common ratio in terms of B and A is this. Now G2 is G2. A into R, then into R. So AR square. So G3 becomes AR cube. Look here, the same number. Usually nth term is AR raised to n minus 1, but here the special case, that is inserting n numbers between two numbers, as in the case of AP. So we can say that the nth term is AR raised to n. Okay, so this you have to remember this also in the case of inserting numbers between two positive numbers, such that the resulting sequence is a GP. So consider the problems. Before that, relation between AM and GM. So let small a and small b be two given numbers. Then their arithmetic mean, AM means arithmetic mean. It is defined as a plus b by 2. And these two numbers, these two must be a positive numbers. So what is their geometric mean? Root of AB. Now what is the relation between AM and GM? So what is, just find what is AM minus GM. A plus b by 2 minus root AB, or that is same as a plus b minus 2 root AB the whole divided by 2. Numerator we can write as a perfect square, root a minus root b whole square. Root a square is a, root b square is b minus 2 root a root b by 2. So numerator is square, means it is always greater than or equal to 0, and by 2, 2 is also a positive number. So AM minus GM is greater than or equal to 0, or what we can write, AM is always AM is greater than or equal to GM. Now problems. Insert two numbers between 3 and 81 so that the resulting sequence is GP. So 3 and 81 are two numbers. Between these two we have to insert two numbers. Only two numbers we have to insert. So here n is 2 and R is, the formula is b by a raised to whole raised to 1 by n plus 1. Okay, and what is a? 3, b is 81. So here 81 by 3 raised to 1 by 2 plus 1, or r is equal to 27 the whole raised to 1 by 3. Cube root of 27, that is 3. So r is 3. So what is G1? G1 is 3 into common ratio AR, that is 9. G2 is AR square, that is 9 into 3. 9 into 3 is 27. So what is the resulting sequence? 3 is the first number, into common ratio 9, into common ratio 27, then 81. Is it a GP? Yes. Find the value of n so that a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n may be the geometric mean between a and b. So given that this one may be the geometric mean between a and b. So geometric mean between a and b, how to write? Is root AB. So root AB is equal to the given fraction, b raised to n plus 1 by a raised to n plus b raised to n, root AB, or a raised to n plus 1 plus b raised to n plus 1 by a raised to n plus b raised to n is equal to root AB, same as a raised to half into b raised to half. Now cross multiply. So a raised to n plus 1 plus b raised to n plus 1 is equal to a raised to half b raised to half into a raised to n plus b raised to n. So a raised to half into a raised to n is a raised to exponent rule n plus half, adding the powers, into b raised to half, plus a raised to half, b raised to half into b raised to n is b raised to n plus half. Here left side a raised to n plus 1 plus b raised to n plus 1. Then a raised to n plus 1. I take this term to left side. Is equal to a raised to half b raised to n plus 1 by 2 minus, here what is the common? A raised to n plus half and n plus 1. N plus 1 means n plus 1 is same as n plus half plus half. So n plus half we can take out. N plus 1 is same as half plus half. Right hand side also we can write like that. Minus b raised to n plus half plus half. So in the left hand side we can take a raised to n plus half outside. So bracket, first term is a raised to half. So when we multiply you have to add the powers since base is same. Then in the second term this taking out means b raised to half is left. Okay. Now right hand side, b raised to the least power, half we can take out. So a raised to half minus b raised to half. Okay. So these two we can cancel, a and b cannot be 0. We can cancel that. Then what we get? N plus half by b raised to n plus half. When we take this term to the denominator, right hand side becomes 1. Or we can write together a by b raised to n plus half is 1. This is possible only if the power is 0, which implies n is equal to minus half. The next is, if am and gm of roots of a quadratic equation are 8 and 5, then obtain the quadratic equation. So if roots of a quadratic equation are given, 10th standard you have studied, if alpha and beta are the roots of a quadratic equation, then how to write the equation? Then equation we can write as x square minus alpha plus beta x plus alpha beta equal to 0. This is a quadratic equation if alpha and beta are the roots of the equation. Here am and gm of roots of a quadratic equation are 8 and 5. So am means 8, gm means 5 of roots of a quadratic equation. So let a and b be the roots of the quadratic equation. Then, so a and b two roots. Am of a and b is given as arithmetic mean, that is given as 8. Arithmetic mean of these two numbers is a plus b by 2, which implies a plus b is 16. Now gm is given as 5. Gm of a and b means root ab. If we square it, ab is equal to 25. Now the question is obtain the quadratic equation. So if a and b are the roots, how to write the equation? X square, therefore quadratic equation is, instead of alpha and beta you have to write a and b. So x square minus of a plus b into x plus ab equal to 0. Now give the value of a plus b and ab. So x square minus 16x plus 25 is equal to 0. That is the required quadratic equation. A and G be arithmetic mean and geometric mean respectively between two positive numbers. Prove that the numbers are a plus or minus root of a plus g into a minus g. So here capital A and capital G denotes AM and GM between two positive numbers. So let two positive numbers be A and B. Okay. Therefore, AM arithmetic mean, that is same as capital letter A. It is given in the question. That is defined as A plus B by 2. Okay. Now GM. GM is as G, capital G, that is root of AB, or G square is equal to AB. Okay. So that's the first equation and second equation. Right. GM is equal to G is equal to root AB, or G square is AB. And we have to prove the numbers. Which are the numbers? A and B. So from the first equation and second equation, you have to find what is A and what is B. Okay. So from first equation, A plus B is equal to 2A. Okay. Or B is equal to 2A minus A. Substitute B in second equation. Therefore, second equation becomes G square is equal to A into 2A minus A. And this capital A and capital G, that are constant. These are the numbers. We don't know the numbers. Let x and y like that. They are variable and this is given values. So that is constant. Now solving, you have to solve this equation. That is G square is equal to 2AA minus A square. Or as a quadratic equation, A square minus okay. This is a quadratic equation in A, which is a quadratic equation in small a. Capital A, G, that two are constants. Okay. So A is just like X. Now quadratic equation, how to solve the quadratic equation? Using quadratic formula we can solve. So A is equal to this 2AG constant. So this is just like x square minus 2AX plus G square equal to 0. Okay. You just think A as X. So how to find X? The formula, quadratic formula, B square minus 4AC by 2A. Okay. Minus B. B means coefficient of this A. That is minus means plus, plus or minus. A means coefficient. First coefficient is 1. Here B is minus 2A and C is G square. B square is 4A square minus 4AC. G square by 2A. 1. Here 4 is common, A square minus G square by 2. Root 4 is 2, we can take 2 outside. A square minus G square we can factorize, A plus G into A minus G, and 2 you can cancel. 2 is common, taking out. So 2 and 2 cancel. So A is equal to, A is one of the number, that is A plus G, A minus. Okay. Now we have to find B also. What is B? Look here, b is 2a minus a. So b is equal to 2a minus small a. That is 2a minus bracket a plus or minus root of a plus g into a minus g. 2a minus a, that becomes a. Then minus plus or minus. So if this is positive, minus into plus becomes minus. If this is negative, negative into negative becomes positive. So there you can write plus or minus. It can be plus or minus. Then root of into a minus g. So a plus or minus root of a plus g into a minus. Now you compare a and b. Both are same. Okay. So the numbers are a plus or minus root of a plus g into a minus g. That is given in the question. Look the question, two positive numbers, prove that the numbers are a plus or minus root of a plus g and root of a minus. Root of a plus g into a minus g. The last one. If the 4th, 10th and 16th terms of a GP are x, y, z respectively, prove that x, y, z are a GP. So if a comma b comma c are in GP, or I will take x, y, z. If x comma y comma z are in GP, then we know that second term by first term is same as third term by second term. When we cross multiply, we get y square is x. So this is a condition for three numbers are in GP. Okay. So the fourth term is given as x and the 10th term is y, 16th term is z. Fourth term is AR raised to 3. So let A be the first term and R be the common ratio. So AR raised to 3 is x. Equation 1. Now A10, 10th term is AR raised to 9 is y. Second one. Then A 16th term is AR raised to 15, that is z. We have to prove x, y, z are in GP. That is x, y, z are in GP means what we have to prove? Y square is equal to x z. So is it satisfy here? What is y square and x z? X into z, that is multiply 1 and 3. AR cube into AR raised to 15. That is a square r raised to 18. Is it same as y square? Y square is equal to a square r raised to 9 square. AR 9 square. What is the answer? Here you have to multiply. Okay. So when we multiply x and z, that is same as y square. So when you get like this, you can conclude therefore x, y, z are in GP. Okay.